This slide is chapter 3 about the methodology of this project. The methodology of the project is the first phase is finding tools and dataset. The project we find tools and we find the malware data, and then the second phase is setting tools and dataset. This project we select the tools and select the malware data, and then the third phase is installing the tools. The project we use the computer or laptop and Windows 7 to install the VK, and then the next phase is information collection, which using the logs format about the log format dataset ARFF or SCV, and then using the machine learning tools and apply the technique and get the outputs, and then information and then the next phase is information analysis, is about when get the output we read this project we read the outputs and analyze the outputs, and then last phase is documenting the result. After analyze the output, this project we compare the outputs and identify the best output and document the that result. And then the next slide is I will explain about the chapter 4, which is analysis and design. So in this slide is the research workflow about this project. The first phase is select tool and dataset. The project will select and review which tool and dataset will be used. And the second phase is define tools and dataset. The tools that determine is welcome machine learning tools, and the dataset is, and then the dataset is the Psm URL. The third phase is installing tools. The hardware requirements use a laptop or computer, and VK will be installed on the Windows 10. And then the next phase is define technique. The technique will be used in this project is support vector machine, random forest, decision tree, and naive Bayes. And then the next phase is collect information. In this phase is the selected vector, different algorithms are applied during this phase, and the result will be collected. And then the next phase is analyze information. The results are analyzed to identify the best algorithms, and then the next phase is compare information. This comparison is done with different technique to get the best result, and the next and then last phase is identify best technique. The result will be documented after comparing the output and identify the best the algorithms. This slide is about the analysis architecture for this project. First, we insert the dataset patient URL into the VK, and then we choose or apply the machine learning techniques, and then we classify the technique, and then we get the result, and we identify the result and documented the result, and then they documented the result. So in this slide is the general flowchart for VK. The first process is selecting 500 documents, and then pre-process the data, and we insert the patient URL dataset format ARFF, and then the dataset is if dataset is valid, it can do the classify the data using machine learning technique. If not valid, it's gonna do the next process, and then we're gonna choose the perform a cross validation or test on a spread dataset, and the next process is process the result, and we prediction information about the result, and then we identify the best result for this project. So in this slide is the justification of the project. The selected malware used is phishing URL. The tool that used is Weka. The machine learning technique that used is naive Bayes, random forest, decision tree, and support vector machine. The category phishing focus is spear phishing, priming, and watering hole phishing. And then the type of attack phishing focus is phishing URL. So in this slide is a summary function tools in machine learning and summary of machine learning techniques. As you can see in table summary of function tools in machine learning, Weka, sklearning, shotgun, and accord.net have all machine learning techniques, which is classification, regression, clustering, and predictive modeling, while TensorFlow does not have all the classification machine learning. This is because the study found that the features about TensorFlow is to provide a library for data flow programming. Therefore, as conclusion that this project will use Weka machine learning tools. This is because although Weka machine learning is similar to others, however, Weka on the other hand is particularly good for machine learning if one manually change hyperparameters, and therefore for ad hoc machine learning research and ethical. And then for summary of machine learning technique, as we can see, all the tools that have the machine learning technique, for example, as you can see in the table, make summaries of machine learning technique. So in this section, I would like to demonstrate the Weka application. So this is the Weka GUI chooser. The application of Weka is have experimented knowledge flow, workbench, and simple CLI. For this project, I will use the Explorer, and then when you click the Explorer, this is the interface about the Explorer. And then for this pre-process is you can see the pre-process. You can open the file, which is you can find insert about your dataset. This is the filter, current relation, selected attributes, and this the detail about the attributes of datasets. And then for filter is if you want to divide your dataset, for the example, you can use the remove percentage. The remove percentage is one if you want to divide for train for your dataset to train the dataset and testing dataset. For example, this is the testing dataset, and then for example, this is the train dataset. You can click OK and then you can apply this. And then for the classify is the allow configuring and executing any of the Weka classifiers on the current datasets. And then the cluster is about can configure and execute any of the Weka clusters. And then associate ni for associate panel can mine the current dataset. And then the select attributes is allow to configure and apply any combination of Weka attributes. For example, you can choose the attribute validators, which is classify attributes and so on. And then you can choose the methods is best first or rankers. And then the attribute selection modes is you can choose the cross validation, float 10, or use full training sets. And then you will get the attribute selection output at this uh, at this section. And then the visualize is displayed as a scatter plot metric for the current dataset. For if you want to see the scatter plot metric uh, about your dataset, you will click the visualize to see the plot, the scaled plot matrix. For the project, I will use the classify. Classify, I will use the that have the random forest. This is the technique or algorithm that have in Weka machine learning tools. For example, I will choose the technique is random forest. For example, the test option, if you want to use 10 dataset, the test option is you can choose use 10 dataset, supply test sets, cross validation, or percentage split, and so on. You can see the option. You can see the option when you click the more option. For example, I use the cross validation float 10s. You also can use the float 11 or 12. For example, I will use the 10s. And then this is the uh, example about this is the attributes for this dataset. And then you need to click start, and then wait the minutes, and then you get the result about the classification. And then you can see this is the classified output about this dataset, and the about the random forest technique or algorithms. This is the correctly classified instances about this algorithm. Random forest is 87.9%. It is the detail about the accuracy by class. You can see the TP rates, false positive rate, precision, recall, F measure, and so on. And then you can see the confusion metric about this about this classified output. And then that's all. That's all for the uh, demonstration about so as conclusion about this project is, in this project the technique we'll be using is SVM, random forest, naive Bayes, and decision tree. And Weka machine learning will be implemented in different technique to get the output. After that, the technique will be compared to determine which is the best technique that have a good result. And then that's all from me. Thank you very much, and assalamualaikum warahmatullahi wabarakatuh.